Hello, and welcome to today's Safety and Health webcast, Working When the Heat is On, Heat Stress Overview and Solutions, sponsored by Ergodyne and Sqwincher. My name is Kyle Morrison. I'm the Senior Associate Editor with Safety and Health magazine, and I'll be moderating today's session. Thank you all for joining us. In a few minutes, we'll start the presentation, but first I'd like to go over a few housekeeping items. The views of the speakers and their organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Mention of any commercial enterprise, product, or publication does not mean the Council or the magazine endorse them. At the end of today's webcast, we'll have a question and answer session. To ask a question, simply type it in the text box located in the lower left-hand corner of your screen, then click the Submit Question button. Feel free to ask your question at any time during the presentation. You don't have to wait for the Q&A session to start to ask your question. We'll try to answer as many questions as we can, but due to the high number of participants today, we may not get to all of the questions. However, any unanswered questions will be forwarded on to today's speakers. For basic troubleshooting information, please click the Help button located on your screen. At the end of the webcast, you'll be asked to complete an evaluation survey, and I'll talk a little bit more about that after the presentation. This webcast will be archived for 3 months, so you can access it after today's live presentation. Within about a day, just return to this URL to access it. Okay, with that, I think we're ready to begin. Our speakers today are Adria Hardy and Jeff Basil. Adria is the product manager at Ergodyne, where she helps protect workers from the elements through training, education, and the development of product solutions. Jeff is Sqwincher's National Director of Accounts and International Business and has extensive experience customizing hydration programs to counteract the effects of heat stress in the workplace. Adria?
Thanks, Kyle, and thanks for joining us today as we move forward to learn about heat stress causes, symptoms, and costs. We're also going to discuss all the latest in OSHA regulations and then critical PPE solutions. As Kyle so eloquently said, my name is Adria Hardy, and I'm a product manager here at Ergodyne for our Elements pillar. I am joined with Jeff Bazel, who is the Director of National Accounts and International Business for Sqwincher. So why don't we go ahead and get started here. Our climate is changing, and we're seeing that, and heat stress is increasingly becoming recognized as a serious hazard across the globe. And the years between 2001 and 2011 were globally among the warmest on record. And just last year, we saw very big signs of our changing climate, including major heat waves across the northern hemisphere, the most notable of those between March and May across the continental U.S. and Europe. We also saw warm spells in late March 2012, resulting in many record-breaking temperatures in Europe and nearly 15,000 new daily records across the U.S. And even Russia, way up there north of us, witnessed the second warmest summer on record since 2010. So, what are the facts? Heat stress is a real occupational hazard, and we've seen that increase, and it can affect anyone and can result in death. According to the National Oceanic and Atmospheric Administration, or NOAA, it's been rated as the #1 weather-related killer, more so than tornadoes or hurricanes. And in fact, looking at a study from the U.S. Bureau of Labor Statistics, there have been 177 worker deaths and over 13,000 cases with days away from work due to exposure of environmental heat in the private sector between 2003 and 2008. And unfortunately, we're seeing the number of worker fatalities due to environmental heat on the rise. And this is a chart pictured here that shows worker fatalities since 2003. And just late last summer, there was a case involving a United States postal worker who died from excessive heat exposure. And USPS was actually cited by OSHA and fined for what? For the lack of training and education. So as our seasons become more extreme and unpredictable, it's really important that we continue to be educated on this very serious occupational hazard and learn how to prevent it. And being aware of heat stress factors, symptoms, and ways of prevention are really detrimental in mitigating those risks and keeping our workers safe. So let's bring it back to the basics. There are really two sets of factors that contribute to heat stress. The first you see here on your screen, they're personal factors. Workers at greatest risk of heat stress include those who are older, who are overweight, who have heart disease or high blood pressure, which Jeff will talk a little bit about later, or those that may take medications that can be affected by extreme heat. Another major contributing factor is dehydration. A dehydrated person is not going to be able to sweat fast enough to dissipate that heat, and that's going to cause their body temperature to rise. Inadequate tolerance to the environment, or what's called acclimatization, is another major factor, and it's important for employers and employees to understand that inadequate acclimatization can endanger anyone exposed to conditions of heat and physical stress significantly more intense than what they may be used to. The second set of factors are environmental, and these factors determine how much an employee's body is heated from external sources. So it's no surprise, you can see the list here, but high temperature, humidity, direct sun or heat obviously are on that list. Included are hot equipment and reflected heat from the ground. Also something to keep in mind, workload intensity and duration are additional factors that can contribute to an employee's heat burden by producing metabolic heat. Protective clothing and then some personal protective equipment can also have an effect on an employee's ability to keep cool through our natural evaporation of sweat and then having contact with that cooler air. If you are in an environment or have workers that are in protective clothing and equipment, obviously their chances of heat stress are increased. In in environments of 81 degrees Fahrenheit or above, experts actually recommend that an employee spend no more than 15 minutes per 1 hour in an impervious suit, whether that be a hazmat suit or whatnot, unless cooling has been provided to that suit and the employee is wearing a heat stress monitor. So among that list of factors, we have high temps and humidity, and those are really the two biggest environmental contributors to heat stress. And these work in combination to create what is called the heat index, and we're probably all familiar with that and look at that most likely in the summer months wherever we live. And this is a heat index chart that's been published by NOAA, which shows that perceived temperature when both air temp and humidity are considered. And you can see that the hotter the temperature in combination with a high humidity, the more dangerous that environment becomes and the more uncomfortable it's going to feel for the worker. So be especially aware of heat-related illnesses when you have workers that are in environments of 85 degrees Fahrenheit or above, and you can see those reflected here in the orange and red zones. So what is a heat-related illness and what signs do I look for? I'm going to throw it on over to my colleague Jeff here.
Thanks, Adria. We're going to talk a little bit about heat-related illnesses, or HRIs, which is an umbrella term we use for several conditions that afflict individuals working in hot or humid environments. There are 5 types listed here: heat rash, heat cramps, heat syncope, heat exhaustion, and heat stroke. Let's start at the least severe and work our way through. Heat rash occurs when sweat ducts become clogged and sweat cannot get to the surface of the skin. We're going to talk about heat cramps, which typically affect workers who are sweating profusely during strenuous activity. Anytime a person sweats, their body's salt and moisture levels are depleted, which over time can produce painful spasm, usually in the legs and the abdomen. These are the 2 least severe HRIs, but still should be taken seriously. Response to an individual exhibiting these signs is to get them to a cool, shaded area, apply something cool on them, and make sure they drink plenty of fluids. Monitor symptoms and seek medical attention if symptoms do not subside or worsen. Talking about heat syncope, which is also known as fainting, is a result of overheating. It is another stage in the same process as heat stroke. It occurs under similar conditions and is not distinguished from the latter by some authorities. The basic symptoms of heat syncope is a body's temperature being above 40 degrees Celsius or 104 degrees Fahrenheit with fainting, and with or without mental confusion, which does occur in heat stroke. Heat syncope is caused by mild overheating with inadequate waters or salts. In young persons, it is far more common than true sunstroke. Heat syncope occurs when the blood pressure is lowered as the body widens its small blood vessels in the skin to radiate heat. Also, water is evaporated from the blood, reducing the blood's volume and therefore lowering blood pressure further. The result is less blood to the brain, causing lightheadedness and fainting. The basic treatment for heat syncope is like that for other types of fainting. The patient is positioned in a seated position with its legs raised. Water is administered slowly, and the patient is moved to a cooler area. The two most severe HRIs are heat exhaustion and heat stroke. Heat exhaustion is a milder form of heat stroke that can develop after the course of several days of exposure to high temperatures and inadequate or unbalanced replacement of fluids. The body's response to this excessive loss of water and salt is through extreme sweating. Untreated heat exhaustion may progress to heat stroke if a worker does not act quickly once seeing someone exhibiting these signs. The final HRI is heat stroke, and is a condition that occurs when the body becomes unable to control its core body temperature and can cause death or permanent disability. Heat stroke is a true medical emergency and can be fatal if not properly and promptly treated. So it's absolutely critical to seek medical attention immediately upon recognizing signs related to this HRI. So to discuss who's at risk for experiencing a heat-related illness, we're going to talk a little bit about what can happen to everybody. Heat stress can strike workers in various jobs and industries. When you hear heat stress, you might think of construction workers doing heavy labor in the heat of the day, or a factory worker confined in a non-air conditioned warehouse. But in reality, many types of industries and work environments can put employees at risk of heat stress. Don't let your crew fall victim to any of these statements on your screen. No one is superhuman, and we all need to take care of ourselves, especially in high heat situation. Mild to moderate symptoms can quickly turn to severe and result in hospitalization or even death. Act immediately once you see early warning signs of a heat-related illness. If supervisors or crews workers do not act quickly, there are three critical risks. First, worker injury. While working under stress, cognitive abilities decrease. Slower reaction time and poor decision-making can lead to an injury. Operating equipment or tools is always dangerous, but even more so when workers are impaired or under stress. Second is property loss or damage. Fine motor skills are often impaired when the body is under stress. Therefore, a worker not performing at peak form can cause accidents resulting in property loss and damage. And finally, productivity will be lost. According to the USA Today, 65% of workers either don't want to work or work at a much slower pace when it gets hot and humid. A stressed body cannot work at optimum speed or performance. Workers' productivity declines as an effect of a heat-related illness. Not only are injuries and property damage and loss of worker productivity major risks, but there's a big cost associated with an inadequate response to heat stress. These figures are taken from the 2010 report by Washington State's Department of Labor. The average workers' compensation claim for injuries related to excessive heat exposure is over $3,000. Average cost per worker for a disabling lost time injury, which is 3 days or more, is more than $26,000. And that cost has increased year over year and does not include any other indirect costs like having to hire and train replacements. Average time lost days per heat-related illness claim is 53 days, and for a fatal accident, the average employer cost is approximately $1.35 million per fatality. The good news is that there is a silver lining. Heat-related illnesses and fatalities are 100% preventable, and I'm going to pass it back to Adria to talk a little bit more about it.
And as we covered in a previous slide, awareness is really key to that prevention, and we've seen increasing awareness and a lot of stricter regulations related to heat stress just within the past several years since 2010. And all of those have really validated that this is a serious occupational hazard. And a couple of years ago, OSHA amped up their stance on the issue with a heat stress campaign offering resources and information for both the employer and the employee. And they've really centered it around a theme called water, rest, and shade. And you see some images here on the screen from that campaign. But really, this isn't a new issue. So where did it all begin? Back in 2005 and 2006, the state of California's OSHA board took a very in-depth look at 71 very serious heat-related investigations in the state. And through their study, it really revealed the risks and dangers related to heat stress. And so I want to pull out a couple of very interesting pieces of information that were discovered through that study that California did. And I have them here on the screen. The first one, all ages were affected from 16 years to 79 years. No one was immune. And in fact, when looking at some more recent data from the Bureau of Labor of Statistics, 60% of the fatalities that occurred in 2009 due to environmental heat were from workers under the age of 45. So we oftentimes oftentimes think it affects older folks, but it really doesn't. No one is immune. 69% of the heat stress cases investigated in the Cal OSHA study involved outdoor work. So that means that the other 31% of the cases occurred indoors. Heat stress doesn't just affect those working in the sun, and Jeff mentioned that. We oftentimes think of that, but that's not always the case. 48% of those most serious heat-related illness cases were among workers performing light to moderate work, reaffirming the fact that heat stress can actually happen in a variety of work environments. 61% of the cases occurred among new hires, their first week on the job. So I talked about acclimatization being a factor contributing to heat stress. So making sure to get your body or get your workers or new hires' bodies acclimated to their environment is really important and key in prevention. And then 78% of those affected were dehydrated despite having drinking water available on the job. This is big. Being dehydrated is a major contributing factor to heat stress, but it's not just about getting water out there, and we'll talk a little bit about that. Jeff's going to mention that in the presentation a little bit later. And then 30% of the most serious heat-related cases resulted in death, and of those not resulting in death, 31% required hospitalization for more than 24 hours. So because of the results of this study, California OSHA kind of took a very big step and decided to take a very serious position on the topic of heat stress. And they strictly enforce a new standard that is centered around the prevention of heat stress in the workplace. And in the next few slides, that's really what I'm going to go over. I'm going to talk about the key provisions of this standard. Since California has historically been in the forefront of rulemaking, that's why we're discussing it. We've also seen other states like Washington State adopt a very similar version. So could this become eventually a federal mandate? Possibly, but definitely there could be other states that take on similar standards, state-specific standards. If you reside in California, compliance with the standard is required. If you don't, it's important that you listen up just for best practice reasons. And further, OSHA does have that general duty clause where an employer is required to take any precaution for the safety of their workers. So the purpose of this standard is really prevention, and there are 6 provisions in the Cal OSHA heat stress standard, again, all centered around prevention in the workplace. So to start out, Part A really outlines the scope and application. The standard applies to all outdoor places of employment. So if we go back to that 2005-2006 Cal OSHA study, they found that 69% of serious heat-related illnesses involved outdoor work. So again, there's a huge chunk of indoor workplaces. So why not include indoor workplaces? Typically, these types of environments are governed by building codes that require sufficient ventilation, so either by natural or mechanical means. And indoor workplaces already are blocking the biggest thing, which would be direct sunlight. So they're already blocking exposure to direct sunlight. With that said, there are obviously still heat stress risks that are associated with indoor environments, especially where you have environments where high heat is required to manufacture goods, or maybe where an employee is required to wear some sort of chemical protective clothing, whether that be a hazmat suit or PPE, that then is going to significantly interfere with our body's natural ability to kind of dissipate that heat. So it's recommended that these employees still be included in some sort of heat stress program as well. And I have a slide on that, and I'll talk a little bit more about that later. Part B really defines heat illness, and it talks about it being a serious medical condition that results from the body's inability to cope with a particular heat load. It also defines environmental risk factors, which you've already covered, and it also defines personal factors, which we covered in a previous slides. I do want to point out, because they pointed out specifically in the standard, acclimatization is included in this and definitely shouldn't be dismissed. It's an immediate consideration that should result in some sort of direct action by an employer, not just for new hires, but also if there's a sudden heat wave, for example, if that puts regular employees that are working at those temperatures into an environment that they're not typically exposed to. So something to consider. Again, of course, new employees are among those most at risk for suffering the consequences of inadequate acclimatization, heat wave or not. Part C requires that an employer provide sufficient quantities of drinking water for employees. And they state in the provision that the water provided must be fresh and pure. It must be suitably cool. They unfortunately do not give a temperature specific, but suitably cool. OSHA recommends anywhere from 50 to 60 degrees. An employer should take into account the air temperature, the humidity, and the nature of the work being performed. Where there's unlimited drinking water not immediately available from some sort of plumbed system, that employer must provide enough water for every employee to be able to drink what they recommend 1 quart of water per hour. So that would be 2 gallons per employee for an 8-hour shift. You're out of compliance if at any time the drinking water is not available to employees, or if the practice is to wait until the water container is empty and then you replenish it. So it has to be a constant flow of water. You're also in violation if the employer is only replenishing the water supply when an employee requests it. The standard not only requires that the water be provided, but also that supervisors encourage employees to drink it frequently. So we go back to the case study done by California, and that showed that although there were 90% of the work sites had water on site, 78% of the employees suffered from a heat illness were dehydrated. Why is that? Because it's not just about providing that water, but it's about making sure to train your employees so that they recognize that their bodies need water, that they need to continue to keep themselves hydrated. So employers must be emphasizing this in training sessions, and they need to be stressing the importance of keeping hydrated throughout the day, especially in very high heat situations. And then Part D of the Cal OSHA standard centers around and requires that employers provide shade when the temperature high for the area is over 85 degrees, and that should be according to the National Weather Service. So if the prediction for the next day is to actually exceed 85 degrees, then the employer is required to provide shade at the beginning of the shift, and that shade must be present throughout. So the employers must also have the capability to provide shade promptly if an employee requests that they put it up. So what's considered shade? According to the Cal OSHA standard, shade is considered blockage of direct sunlight. So blockage is sufficient when objects don't cast a shadow. So shade can be provided, you could provide it by buildings, canopies, shelters, any other partial or temporary structures that are going to be ventilated or open to some air movement, and then again block that direct sunlight. Trees are an acceptable compliant source if they're dense enough where they're going to provide complete blockage of the sun. The interior of a vehicle may not be used as shade unless the vehicle is air conditioned and the air conditioner is operating. Further, if we look at metal storage sheds, those also do not meet the definition of shade unless they're going to provide some sort of ventilation and most likely some type of air conditioning. Cal OSHA considers the amount of shade to be sufficient if it accommodates 25% of the employees on a shift at the same time. All of the employees must be able to sit comfortably in the shade without touching each other, and they also must avoid contact with the bare soil. So that would be, you'd be in compliance if you provided chairs, benches, even sheets or towels, any item that's going to allow your employee to sit without contacting dirt. The nearest shaded area must be as close as possible, and Cal OSHA recommends that it needs to be located no more than a quarter of a mile or 5-minute walking distance, whichever is shorter. So remember, it sounds like a lot to think about, a lot of details here, but really the purpose of this provision and the purpose of shade is to provide employees with a recovery period, which is really detrimental to that prevention of heat illness. So access to shade must be allowed at all times, and they recommend for a minimum of 5 minutes anytime an employee needs or feels the need to take a break. The Part E provision was actually a late addition to the standard. They added this in August 2010, and it covers all, not just some, outdoor applications. So this would mean if you're in ag, if you're in construction, landscaping, oil and gas, transportation, it covers it all. Why? as the heat index chart showed earlier, obviously the hotter the temperature and the higher the humidity, the more workers are in danger of experiencing some sort of heat stress. So an employer is required to implement specific high heat procedures when that temperature exceeds or equals 95 degrees. So initially it's 85, but this one kicks in at 95 degrees. And it's really more for the supervisors. It requires that a supervisor maintain communication with employees at the work site so that they can very quickly call emergency services if needed. It requires a supervisor to monitor and observe heat stress signs and symptoms. And it also requires the supervisor to encourage employees to continue to hydrate. It also specifically has a bullet point in the standard in this particular provision for an employer to be extra vigilant if they have any new hires. The new hires are considered first 14 days on the job, so they need to be looking to make sure that those new hires are getting acclimated. And then the last part, Part F, it refers to employee and supervisor training. If we go back again to the OSHA study, but it showed that 63% of the supervisors of employees who died from heat stroke actually had not been trained in the prevention of heat illness. And so that's a scary statistic, but it's really up to the employer to develop and implement effective procedures, whether those be related to, replenishing water or electrolytes during the shift as needed, whether it be giving access for employees to shade. They should be talking about training related to responding to symptoms of possible heat illness, how medical services will be contacted if that should be necessary. Some employers may choose to integrate these types of procedures into their injury and illness prevention program, and frequent reinforcement and training is really the most effective. I've heard of some employers using what's called a tailgate meeting, where they do every day they talk about a specific safety reminder on whatever issue is relevant for that day's work, and they talk about that, and that's given at the start of the work period. So it's important. Training and education are very important. So fines for the standard in the state of California reached close to $250,000 last year alone, so it's definitely not something to take lightly. And again, like I said, if you live in California, it's important that you comply. If you don't, you not only risk a very hefty fine, but you also risk what's called an order prohibiting use, or an OPU, and a serious citation if the heat and lack of facilities create a very imminent hazard. An OPU can be issued if the temperature is at or above 95 degrees and you don't have water, shade, training, or emergency procedures in place, or if the temperature is at or above that 85-degree mark that I talked about earlier, and that's going to put employees in danger. So an OPU is very serious. It not only is going to shut down your operation, but work will not be allowed to resume until the employer actually demonstrates that the hazard has been corrected. But again, like I stated earlier, no matter what state you reside in, it's really important that employers have a general duty under that general duty clause under OSHA's Occupational Health and Safety Act to take every reasonable precaution for the protection of a worker. And that would include developing heat stress policies and procedures to protect workers in hot environments, whether that be due to weather or some sort of process. And fines can and have been levied. When we talked about USPS, they have been levied under this general duty clause for unsafe work practices or a lack of training. So it's really important that people get serious about this issue. So I want to briefly talk to those folks who may be in an indoor application, because like I said earlier, heat stress isn't just an issue for outdoor environments, but it absolutely occurs in environments where employees are near sources of heat, or they may be inside buildings of limited cooling capabilities. A lot of times we normally associate heat stress with summer months, but in workplaces like a foundry, for example, or maybe a commercial bakery or laundry, heat is actually a year-round hazard. So as I stated earlier, typically these environments are governed by building codes, so they require some sort of sufficient ventilation. But with that said, there are several states that specifically address heat stress prevention strategies in indoor applications. The first one being California, no surprise there. They direct their employers to address any safety or safety hazards or health concerns to their work site, which would include heat illness, in their injury and illness prevention program. And then in Minnesota, heat is actually recognized under the state's Employee Right to Know Act as a harmful physical agent. Their heat stress guide, while it applies to indoor workrooms and more general industry only, it encourages that employers whose employees are at risk for a heat-related illness take precautions. And they also encourage those folks to put together some sort of prevention plan related to indoor applications. And so if you're looking to develop a prevention plan for an indoor application, we have listed on the screen here 5 preventative actions, and these are based on recommendations from OSHA. And these are some things you should think about including in your plan. So the first one being encourage employees to keep hydrated. They recommend drinking 1 cup every 20 minutes or 1 quart per hour. Sounds familiar, right? The same is true with outdoor applications. They also recommend resting in cooler areas, set acceptable exposure times, and allow sufficient recovery times. Give time to new hires, especially, or maybe back-to-work employees, so they can acclimatize to the environment. Develop some sort of training schedule for workers. You want to be basing that on signs and symptoms to look for and measures that employees can take to protect themselves, and then have an emergency plan in place so that everybody knows what to do if there is some sort of emergency related to heat stress. So the bottom line, really, heat stress isn't going away, and it's really about prevention. And so I'm going to lead on over to Jeff, and he's going to talk a little bit about how we prevent heat stress in the workplace.
Thanks, Adria. And yes, talking about prevention in the workplace, we commonly use what we call the hierarchy of controls, which is provided by the National Institute of Occupational Safety and Health, which is something that's used to control exposure to the occupational hazard and a fundamental method for protecting the worker. The hierarchy of controls has been used as a means of determining how to implement a feasible and effective control. The idea behind the hierarchy is that the control method at the top of the list are more effective in protecting workers than those that are at the bottom of the list. Elimination and substitution are at the top, and while most effective at reducing the hazards, also tend to be the most difficult to implement in an existing process. If the process is still in the design or the development stage, elimination and substitution of the hazard may be inexpensive and simple to implement. For an existing process that you may have, major changes in equipment and procedures may be required to eliminate or substitute for a hazard. If we apply these 2 controls to heat stress, we find that it is impossible to eliminate or substitute the sun or equipment or PPE required to do the job, which would make it difficult to comply. So today we'll focus on the bottom 3 as they are the most common controls because they are easily implemented and less costly. Third in the list of hierarchy of controls is engineering. Engineering controls are used to remove or place a barrier between the worker and the hazard. Well-designed engineering controls can be highly effective in protecting workers and will typically be independent of worker interaction to provide this high level of protection. The initial cost of engineering controls can be higher than the cost of administrative or personal protective controls, but over the long term, operating costs are frequently lower, and you'll probably see in some instances they can provide a cost savings in other areas of the process. So one example of providing a control would be providing shelter for the worker, which blocks the direct sunlight and gives them a place to rest, get hydrated, and keep cool. This type of solution can be considered for work zones that are exposed to high temperatures and direct sun ray. Looking at administrative controls and personal protective equipment, you'll find that they are frequently used with existing processes where hazards are not particularly well controlled. Administrative controls and personal protective equipment controls are relatively inexpensive and easy to implement. When we talk heat stress prevention and providing some sort of an administrative control, keeping hydrated is going to be the key component. Dehydration is a major factor contributing to heat stress. A dehydrated person is not able to sweat fast enough to dissipate the heat, which causes the body's temperature to rise and heat illnesses to be inevitable. When looking at a 2006 Cal OSHA heat illness study, it was showed that 78% of workers suffering from heat illnesses were dehydrated despite having water available. Many workers may not recognize that their bodies need hydration. This is an unfortunate but very preventable cause of heat illness. And we're talking about perspiration and having that be the body's main form of heat stress control. Hydrating replenishment is key to replace what you are losing through your sweat. When we perspire, we not only lose the water in our bodies, but we also lose the vital nutrients and minerals known as electrolytes, which are burned during our high heat activities. You can think of electrolytes as the body's form of fuel. Without replenishment, it's difficult for the body to function at a normal and productive level. When restoring a worker's hydration, water alone will not replace the vital electrolytes needed as fuel. Electrolyte beverages are absorbed into the body faster than water alone, and studies have found that workers will drink electrolyte beverages more often than water alone, due to their increased palatability or taste. Hypertension and diabetes, when looking at a hydration program, are going to be two medical preconditions to be mindful of within your workforce. Studies have found that 33% of industrial workers suffer from hypertension and high blood pressure, which is with a significant portion of that number not even being aware of that condition within their bodies. When dealing with these conditions, a low sodium, low calorie diet is needed to control the problem. Another precondition to be aware of is diabetes. The diabetic population represents roughly 12% in the U.S. and continues to increase year over year. When designing a hydration program that includes electrolytes, be mindful of any medical preconditions that exist within your workforce and provide an electrolyte beverage that will both be accepted and be healthy for all of your workers. Too often workers show up to work already dehydrated, and what you'll find, the use of alcohol, a poor diet, and consumption of caffeine are all going to be contributing factors to an individual being dehydrated. Alcohol and caffeine are diuretics, which means water is not retained in the system. Education is key to teaching your people how to hydrate themselves, not only at work, but at home as well. Medical preconditions can complicate using electrolyte drinks because of high salts or sugars. Hypertension and diabetes are at epidemic levels in this country, so providing the proper electrolyte replacement drink is always going to be critical, and we'll be mindful of any existing health issues. Passing it back to Adria to talk a little bit about the personal protective equipment we can use among the hierarchy of controls.
Yeah, thanks, Jeff. The last control on the hierarchy is really the implementation of PPE, and there are several different types of PPE that can help regulate a person's core body temperature and help basically keep them more productive to kind of fight those effects of heat stress. And in order for you to sort of look and select the right technology for your workers, I'm going to review the three most common types of cooling PPE. And the first one that you'll most often see in the market is evaporative. So these evaporative technologies use some sort of evaporative cooling process that's simple to activate and typically holds a significantly cooler temperature than ambient air. And you can see these in cooling bandanas, in headbands, in do-rags, hard hat inserts, those types of PPE. When you use these, simply place an evaporative cooling product in an area where you have large blood vessels that are located near the surface of the skin, and that's going to really help to keep that core body temperature in check and regulated. And so options would be around somebody's neck, in the crook of their arm, or in the crook of their elbow, on the outside of their elbow, possibly in armpits, or actually in the groin area. These types of products typically require some sort of airflow, as that's kind of how they get their cooling sensation from that evaporation process. So if you're in a work zone that's hot and also windy, this may be a good type of PPE to consider. we all know we sweat. Sweat is actually our body's natural way of preventing a heat-related illness, and that's a really good thing. But obviously, it's not a good thing when that sweat gets in your eyes or gets on your hands, and that's not safe. So there's another type of PPE called absorptive cooling products, and that would include terry cloths, sponges, any sort of high-performance technical fabrics that can help trap or move sweat away from a worker's eyes and off of their hands. And these products are really perfect for jobs that may require high levels of mobility. Oftentimes they're tied around somebody's head or attached to some sort of hard hat. And then the third type of cooling PPE is phase change products. Phase change products incorporate substances, it's kind of a mouthful, that utilizes latent heat in order to maintain a constant temperature regardless of what the ambient temperature is going on out in the outside environment. And these types of products are perfect for very extreme heat environments. So if a worker's wearing some sort of constrictive protective gear, like a hazmat suit, this would be a perfect product to consider. Washington State has a heat stress standard like I talked about earlier, and it actually kicks in at 52 degrees in environments where 52 degrees is for those wearing any sort of vapor-proof or chemical-resistant suit. And like I talked about, but any extra PPE clothing like a hazmat suit is going to heighten someone's concern for heat stress. The nice thing about phase change products is that unlike evaporative products that may require some sort of airflow to keep cool, these products don't require any sort of airflow, and so they're perfect in these more extreme environments.
To talk about a few key takeaways from our presentation today, and kind of breaking it out by supervisor versus your crew member or your workforce. If you are a supervisor, we suggest you have fresh, cool drinking water and electrolytes available. You provide shade for breaks when workers need to recover. You educate your crew on the common signs and ways to prevent a heat-related illness. Select a designated person to notify for emergencies. Remember, workers in high or very high and extreme heat index areas should be monitored constantly. If you are a worker or a part of a crew working in a high heat temperature, use a buddy system so that you can observe the signs and symptoms of your fellow coworkers and be able to tell somebody if they appear to be suffering or transitioning into a heat-related illness. Take more breaks and do less strenuous work during the first weeks. Rest in shade to cool down. Remember to drink plenty of fluids, approximately 1 liter per every hour, and wear personal protective gear as we've discussed today to help prevent any high heat illnesses. As we close out our presentation, both Adrian and I hope that we were able to give you a better understanding of heat stress and how it is a real occupational hazard. As I stated earlier, awareness and education is really key to prevention, and Ergodyne and Sqwincher can provide you with an abundance of heat stress resources and product solutions to help keep your team safe this summer. You can see all of these resources listed here, anything from trainings to webinars to posters and technical papers. So please keep in mind that we are here to help and here to answer any questions that you have. And remember, more than anything else, heat-related illnesses and death are 100% preventable. So be informed, plan ahead, take action for your safety and the safety of your workers, and really be aware of what's going on in your work environment. So at this point in time, I believe we are going to pass it to Kyle, who is going to walk us through some questions.
Great, yeah. Thank you both for that wonderful presentation. Before we get to the Q&A, I wanted to remind everybody about the short evaluation survey I mentioned at the top of the presentation. It should be appearing on your screen now. We just ask that you fill it out and let us know your thoughts. So your input is important because it helps improve future webcasts. So please do take the time to fill out the survey. If you don't see the evaluation, turn off your pop-up blocker because it will be a pop-up window that will appear. All right, let's get to some of the questions. I want to go back to something that was mentioned at the beginning of the presentation regarding the flow from heat rash and so forth all the way up to heat stroke. Workers who are out in the heat, do they always start with heat rash and then progress upwards to heat stroke, or can a worker just suddenly have heat stroke?
I'll take that. That's a great question. No, obviously there's more severe and less severe heat-related illnesses, but those aren't, it's not necessary for a worker to go in that order. And in fact, like we talked about, or what Jeff mentioned, heat exhaustion actually can happen over the period of several days. You'll see that some of the signs and symptoms look very similar among all of the five, but absolutely not. They're all basically separate conditions that are, brought on by excessive exposure to heat.
Okay, great. Thank you. We've gotten some questions here regarding the type of hydration workers should use. Is there a difference between, let's say, just water and sports drinks or electrolyte drinks? Which is the best for any given temperature?
I'll take that question. I think the key way to answer that question is going to be, remember, when you are sweating and you are working in a high heat environment, through your perspiration you do lose the hydration of the water within your system in your body, but you're also going to lose the sodium, the potassium, the critical elements and minerals that are a part of your hydration and a part of the fuel for your muscles. When you drink water, you're only going to place the hydration. When you do consume an electrolyte beverage, those beverages are formulated to have the appropriate levels of sodium and potassium, so you will get that added benefit from a sports drink that you would not get out of just water alone. So we encourage a combination of both, but remembering that the potassiums and the sodiums are going to be important part of rehydration, and that is the key difference to water.
Okay. We had another question here. This is kind of an unusual one for me, but what are your thoughts on the use of pickle juice to relieve cramps, heat cramps?
Actually, Kyle, not surprising to me because I get that question quite a bit. There was a period in time where pickle juice was used as a way to hydrate, and the reason for that, if you think of a pickle and the juice that the pickle is in, it's very salty and loaded with sodium. Sodium is a component of rehydration and a component of electrolytes. It's used as the key way to absorb at a higher rate the water and the moisture within your system. So when you do consume pickle juice, you are going to increase the rate of absorption, of that liquid into your system. What pickle juice does not have is going to be those level of potassium, which again is going to be used to get the fuel, the potassium, back into the muscles. So while I won't say it's not a good source for hydration, you are going to be missing some of those critical elements that are included in electrolyte sports drinks like potassium. So it is it's kind of similar to the salt tabs you used to see years and years ago, dumping salt into water. The sodium salt is again going to increase the rate at which the water and hydration gets into your system, but sports drinks are going to have the potassium levels that you want to see as well.
Okay. You mentioned earlier, it was mentioned that one should drink so much water for per hour. Is that kind of like the standard amount of water that we should drink? I believe you said 1 liter for every hour. Does that change at all depending on the temperatures, if it's hotter out or if they're in more sunlight or anything?
Yeah, I mean, we can only give what the standards recommend, and according to the OSHA standard, they actually recommend that employers provide enough water for an employee to drink 1 quart of water per hour throughout their entire 8-hour shift. So again, like, you're absolutely right. I mean, everybody's different. We don't all require. I can't give you a nice clean answer on that. There's a lot of factors that are involved in that. Obviously, your work zone that you're in, the temperatures that you're in, obviously your weight and all of those sorts of things. So it's important that we're never, I can't give you a specific amount, but it's, all I can give is kind of a recommended amount, and that is what OSHA says, and that's about 1 quart per hour.
Okay.
Yeah.
We have a lot of questions on hydration. I want to get back to them, but I want to get to a couple non-hydration related questions before we dive back into them. No pun intended. Want to talk a little bit about indoor areas. Adria, I believe you talked a little bit about that, but what about for a facility that perhaps is not climate controlled? What are the responsibilities of the employer in that situation? Do they have to monitor the temperature and humidity levels inside that facility or provide more breaks?
Yeah, that's a tough question. The only thing that I could suggest for those types of situations would be to have the employer buy a heat stress monitor, which we didn't really talk about today, but that would, a heat stress monitor is nice because it takes into account a bunch of different factors that make up, it's not just looking at the air temperature, but it's taking into account a lot of other factors. And that way you can kind of find where your hot zones are. And then obviously then, detail out appropriate preventative actions based on those environments. So yes, it could be, allowing your employees to take more breaks. It could be, encouraging them, obviously, frequently drinking and keeping hydrated, all of those sorts of things. It kind of just depends, but I would say that would be a good place for somebody in that environment to start.
Okay. I guess I suppose this next question could entail both indoor and outdoor, but what is the best way to track some of these numbers and how employers should go about deciding when to give these breaks?
Yeah, I think that's sort of up to, I wish I had a clean answer for that. I think it's really up to the employer to who understands the environment, a supervisor who's there every day. I don't know. I can't recommend a certain amount of breaks. It really depends on the environment and kind of the conditions that a person's in. But of course, one of the biggest things is to when training and talking with your employees, when you talk about that, make sure that you encourage them to take a break on their own. When somebody starts seeing signs and symptoms that they actually don't, that they shouldn't be feeling like they can't take a break and they're only allowed so many, that they go into the break room and sit down for 5 minutes or whatnot when they need to, especially in really high heat environments.
In high heat environments, is it recommended that individuals take their break before they feel utterly exhausted, or is it okay to wait until they just can't go on anymore before they take the break?
Yeah, absolutely. I mean, obviously, Jeff mentioned it, but mild symptoms of heat illness very quickly can turn to, very severe conditions. So immediately when you start to feel lightheaded, when you start to feel fatigued, when you start to feel, dehydrated and all those things, or, you go to the bathroom and you see the color of your urine, you need to make sure to recognize a lot of those early warning signs before it gets too late. Because like I said, over a course of days, those can very quickly add up to something much more serious, which could be, heat stroke. So
I'm going to add something there too, Kyle. I think, when we were talking about the hierarchy of controls and looking at the administrative controls and PPE, the key element there is it's all proactive controls. We don't wait until we see the signs and symptoms, but we implement the appropriate precautions, both from a PPE and a hydration standpoint, ongoing, so that our workers never get to that point. You put together the breaks so that there is a scheduled break every hour, so that the employee doesn't have to take the time to make the decision on their own. They don't get that decision. They are on that schedule. They have the PPE in place and they're actively using it, so that it doesn't get to the point where you have to measure your urine or where you are within an HRI, but you're never going to even get to that point because of what you've done. So just my 2 cents there. Kyle, do we have any more questions that we wanted to answer at this point in time?
For folks who are wearing flame-resistant material, what steps should they take?
Obviously, if you're in an environment where you're wearing some sort of FRC, coverall or whatnot, then it probably would make sense for you to look for an accessory product that's also flame resistant. So whether, that be a cooling bandana or a do-rag, or whether that be in the wintertime and it's a winter liner or a balaclava, it would make sense. Obviously, you would want to protect protect yourself in that way from that hazard as well. And there are lots of products in the market today that offer a kind of a dual hazard where they're giving you the benefits of the cooling PPE, for the heat stress, but then also have been tested to some of those standards, whether it be for arc flash or flash fire. They've undergone some flame-resistant testing as well. So definitely something to consider when you're in those types of environments, and they're absolutely available in the market.
Okay, thank you. What about situations when employees perhaps are resistant to things like taking their break or drinking water? What can an employer do in that situation to make sure that they're still protecting their employee?
I think in that situation, Kyle, I wish I could answer that, but I think that reflects back onto the employee and the employer and really understanding why they are being hesitant or reluctant to take a break, to drink water, to use a PPE cooling product. In this scenario and for the hazard and heat that we're discussing, I would be shocked if I was a worker and when I'm hot didn't want to cool down, when I'm thirsty if I didn't want to drink. So I think you would find an underlying root cause that may be independent of the actual controls you're trying to implement, hydration or cooling. So it would be interesting and really understanding what's driving that decision to migrate away from the PPE and administrative controls.
Okay, I want to go back real quick to the water and electrolyte drink issue I brought up earlier. Is there a ratio for when both are made available? Should employees rather drink X amount of water for every X amount of electrolyte drinks they have? How should they approach this issue?
There is not a ratio that is published. We support a program that includes both water and electrolytes that are consumed at the same time, but not as a mixed product, but water as an independent source as well as an electrolyte beverage, and having them both available to comply with the hydration guidelines of 1 liter per hour. So there is nothing that breaks down X number of ounces of electrolytes for every X ounce of water, but the consumption of both is going to both hydrate as well as replenish the sodiums and potassiums in the overall body. So being mindful of that is probably the most critical part of it, and educating your employees as to why they would consume an electrolyte drink along with just standard H2O to help them understand what it's doing for their body and what that will mean in terms of their work function.
Is there a risk? I know we talked about a lot about not being hydrated enough, but is there a risk of drinking too much of these electrolyte drinks or too much water? Too much of anything is always going to be there. You can always drink too much of something, whether it's water, whether it's an electrolyte beverage, whether it is a soda. Too much is always going to be something to be mindful of. What is too much? The only way you can really understand what too much is by listening to your body. Obviously, urine and you going to the bathroom is going to be a key indication of the amount of fluid and hydration you have in your system. You've seen on the presentation that there is a urine chart. The color of your urine is going to help you understand your hydration level. We don't often see people getting into a situation, especially employees that are working in a high heat environment, that they're drinking too much. Not to say it can't happen. I know that it is something that is asked quite a bit. But listening to your body and educating again your employees as to why and what they're consuming is going to help them realize if they have gotten to the point where their hydration levels are appropriate or if they're not. So hopefully that answers the question again. I think education is maybe the main takeaway there. Okay, thank you, Jeff. We have time for one last question. Are there any additional hydration tips for employees who smoke? Are they at an increased dehydration risk?
I think what you're going to find there is anybody that's smoking is going to have an increased maybe medical preconditions, the rate at which, depending on the length that they've been smoking and what it means to their overall body, you will find that they will exert maybe more energy in a high heat area, which is going to cause their body to work harder to maintain their productivity, which is going to cause them to potentially migrate into a heat illness sooner or quicker than maybe someone that does not smoke. Again, I can't segregate one from the other, but what I can tell you is a worker that is smoking is going to have to work harder to maintain a productive level, which could cause them to sweat more, overheat possibly quicker than the next guy. There's no science behind that, but it is. I think that would be just common sense when looking at your workforce and looking at those who smoke and don't smoke. And that gets into a little bit of the contributing factors, as I mentioned: alcohol consumption, a poor diet. I would throw smoking in there as well as something to be mindful of when evaluating your workforce and understanding what they may be bringing to the job site when they leave their homes.
Okay, great. Thank you. Unfortunately, we have run out of time, so I apologize to everyone who asked questions, but we didn't get a chance to answer them. But remember, all of these unanswered questions will be forwarded on to our speakers today. Once again, I hope you take the time to fill out the evaluation survey that popped up on your screen early to give us your feedback. And with that, that concludes today's Safety and Health Magazine webcast. I'd like to thank Adria, Jeff, Ergodyne, Sqwincher, and all of you for listening in. So thank you, and have a wonderful day.